Hey guys, I'm thinking about starting a video series like this and just explaining things that people might not get or whatever. So, it's in a couple hours the mastering engineering assignments due, and I decided I'd quickly make a video about it, see how it goes, and if everybody understands what's going on. And if you don't get it, well, this is a quick explanation of what's going on. So, the first problem that we have in mastering engineering, this is assignment 7, is we have a fireman who's, I'm not very good at pictures, so I'm just going to draw him here. He's got a hose of some sort, and he's trying to hit this window down here, which has fire in it. So let me just draw fire. So that window's on fire, and he's trying to hit it. Now, we're given a couple numbers here. I'm just going to draw the lines here. There is a line across, the horizontal, and then there's a line downwards. And we're told to find theta, where this is the speed of his water, EA. We're told to find the two possible answers for this theta that would result in him landing here, in the water. That would result in the water hitting the window. So the numbers we're given are, this is some distance. I'm going to call it distance 1, and the distance from here, which is where the water hose is, to the window, some distance 2. I'm not going to use actual numbers just because every person's number is different, so yeah, like I don't want to plug in my numbers. So some people might be asking, why are there two different thetas? Well, the answer is he could also potentially shoot above, like this, and still land in the window, in which case theta would be here. So this is theta 1, this is theta 2. So that's it. Those are the two possible thetas. The easiest way to do this question, and this is how I did it, to be honest, is the range formula. Now, they tell you to define the positive theta as this one, but I'm going to define it as this one. I'm going to define the positive theta as theta 2. And I'm just gonna use the range formula here. Now, for those of you guys who don't know the range formula, it is distance equals v over g cos of theta times v sine theta plus root v sine theta squared plus 2g y naught. The range formula you might have seen in high school is v squared sine 2 theta over g, but that is a range formula if you have no initial displacement, like if you're just going from flat to flat. As you can see, we're not going from flat to flat, we're going from here, and we're going through the horizontal, and we're going below where it actually started. So we need to use this. Now, all the numbers that were given are in feet. So G here is, what is it? Is it 32.2, I think? Whatever G, this number might be wrong, but whatever G is in feet, I'm pretty sure it's 32.2 feet per second squared. And your VA is still the same, and your cos theta is this angle here, velocity, Now your y is the initial displacement above. So this formula is meant to be used for situations like this, where you have this kind of a situation. and you have a projectile motion, and you're trying to find this distance. That's originally what this equation is used for, where this is y naught. Now we can do the same thing here, except we just say y naught to be distance 2 here. Because if you look at this, it's very similar to this one up here, because you're initially displaced above where you want to land by d2, and your distance, your range, is d1. So you can say this is d1, and instead of y naught, you can write d2. And this, and then I would highly suggest don't try to solve this by hand for theta. It's going to take forever. Use the solve function on your calculator. All calculators have them, the TI-83 or 84. I believe you go into math and go solver, and then type in your equation. Since it is a bit of a tricky equation, it will take it a while, but it will give you some bizarre numbers. It'll give you something like negative 2,900. I don't even know. I'm making up numbers here. Say it gives you negative 2,900. Then all you got to actually, I'm gonna make this number a little bit nicer. Say it gives you negative 3,649 degrees. Well, we know that going around, once around a circle is 360 degrees, so we can get rid of the 3,600 because 360 goes into it 10 times, because the 3,600 corresponds with 10 full revolutions. So this is equivalent to negative 49 degrees, which would result in an angle of 49 degrees downwards. And then your second angle, once you get the 360 factor out, it should be something. It should be negative something, and it should be below 360, and that results in a line up here, which gives you a positive theta here. So this is really all you need to know for this one. It's called the range formula. It's really good to just memorize it. It might seem a bit daunting at first, but it's not really that hard to understand. And yeah, really that's basically just how you do the first question without doing too much work. Just use the range formula. So, on to the next.